Our next session puts the spotlight firmly on these emerging innovators and entrepreneurs. These are going to, well, we're going to be looking at five magnificent individuals, mostly from Europe, mostly from the Innovators Under 35 program, and mostly evolving the state of the art in artificial intelligence. And to kick us off, we're going to have an opening talk from Nora Caldy, who is founder and CEO of NURITAS in Dublin. Nora has a PhD in molecular evolution and bioinformatics, and her company uses AI to analyze food peptide molecules to find ingredients with potential health benefits. Over to you, Nora.
Thanks a million. I'm really happy to be here. It's a pity I couldn't be present physically, but hopefully things are moving and improving now. Many years ago, when I first got my my master's in pure mathematics, it was that summer. I remember walking down the street and I bumped into our family GP. So our family doctor, and you know, kind of the conversation started, and she's like, "How are your parents? How are you? And what are you up to?" And I said to her, "I just got my master's in pure mathematics," and she said to me, "Oh, interesting. What can you do with pure mathematics? You know, do you want to be a teacher?" I'm like, "No, not particularly." I didn't want to be a teacher. I love that profession, but I wasn't moving towards that. But she couldn't find one area where pure mathematics could be applied, and that's crazy. And I think little did she know, I was always attracted to life science, and today I just want to talk to you a little bit about how bringing together totally different industries like mathematics and pure mathematics, in my case, very theoretical, is the whole area of biology and life sciences, and how you can transform a whole area using that background. So everything I worked for since doing through my PhD and drug discovery and so forth was really about empowering this transformation of health and sustainable food by really unlocking the power of nature. And what's really interesting, that realization for me very early on in my career, that nature has the answer to almost every question we have. It's already produced in nature. Nature has found a solution. But really the problem is, well, how can we find those solutions better? What if we could decode, you know, the hidden language of nature, and identify incredible molecules that have been, again, developed by nature to improve human health? How can we, you know, accelerate that discovery? How can we find those hidden secrets? And the realization for me, this is the reason I went into this area personally and then founded the company NURITAS, and NURITAS has taken it to the next level, is that the real issue and the real problem in discovering active ingredients that can improve human health, discovered in nature, is that it takes decades and decades, you know. So if you think about it, if you think simply about the whole area of, let's say, food and health and well-being, etc., some of the ingredients that are currently used, like omega-3, omega-6, the vitamins, the minerals, all these have taken about 100 years to discover and take to market. First, you know, you randomly discover a molecule somewhere in a lab, then it takes you many, many, many decades to understand what that molecule actually does. And then after that, you need to prove it, and then you need to scale it, and so on and so forth. And it takes about 3,200 years cycles to identify natural ingredients that can actually clinically proven to improve human health. And the reason for that is that nature has, you know, if you take any plant within nature or any source material, you have trillions of different molecules all swimming within that one source. You take an apple, I always say this, but an apple has more molecular data than all social media put together since the inception of social media. And we know very little about the content of those natural ingredients. So being able to decipher that information and identify the one active or two actives and associate them to a health benefit has been extremely, extremely hard and cannot be really done with traditional serendipity research within the lab. where you're taking a molecule and you're testing it, and you're doing even high throughput screening does not work in this area. So the question is, how do we solve this? How do we identify a way to decipher nature's language and identify these molecules faster? And really, that's what my whole career has been driven towards, and again, what NURITAS came about to do. And what's interesting coming into this area from a mathematical point of view and doing a PhD in this area, I realized that the only solution for this is using AI, artificial intelligence, and other technologies in order to remove the serendipity research and focus really the technology on the specific molecules and then taking them to the lab and testing them forward. So the solution is really what we developed is a platform called Amplify, which stands for NURITAS Peptide Finder. And what this technology is capable of doing is that it's capable of literally data mining, so going through different plants around the world. We're focused at the moment on plants and specifically on foods. We can literally look at all types of organic matter. And using our technology, which is an integration, obviously, of AI, lab work, proteomics, and peptidomics, different areas, and manufacturing and production as well, we're capable of looking into those plants, identifying the subsets of molecules are interesting, and what those molecules, what those benefits in humans can be. And then we create these powders, what we call the NURITAS Inside. So these are the NURITAS Inside, like the Intel Inside, but the NURITAS Inside ingredients that are beginning to transform human health through the addition of these ingredients into our foods, our medical foods, our dietary supplements, our personal care, and in the future, our medicine as well. So the cycles we have achieved now, as opposed to the 30, 100-year cycles, is about an under 2-year cycle using AI to accelerate that discovery. And I can explain a little bit more. So just to come back one step further, the types of molecules we're interested in are what we call the language of nature. So the language of nature is actually peptides. So peptides are the major signaling molecule in the human body. A lot of the signals that occur within us occur through peptides. There are peptides everywhere in everything we eat. So when we consume plants, we basically break the plant protein. So peptides are basically short proteins. So when we eat plants, we break them down through our digestive system, and it turns into nutrition, so nutrients. What we have found is we have found a technology that's capable of finding peptides, these short proteins that are locked within the protein itself, plant, and we're capable of identifying those peptides, unlocking them, making them available, so that humans not only get the nutritional benefits of the plant, but they also get the health benefits that we unlock via a very specific enzymatic reaction within the plant itself. So all these benefits are otherwise lost when you eat the plant itself. And this is really important. And so peptides are the language of communication. We can literally modulate anything via peptides. We have found ways now to identify them, to make them more orally available, so that we can focus on certain health benefits, which I can explain a little later on as well, identify peptides within plants, and create these ingredients with enriched peptides for specific health benefits. And again, this would have taken, decades and decades to do. We're capable now of doing the full cycle from discovery all the way into clinical and out of clinical, commercial, and taking it commercially in less than 2 years. So how it works from a high viewpoint, we start with a very clear consumer need. That consumer need can be, we want to reduce inflammation, circulation inflammation. We want to improve strength. We want to reduce glycated hemoglobin for pre-diabetics, for example. So it starts off with a very clear consumer need. That consumer need then is translated into a biological question, and the biological question is an integration of different pathways, human pathways. I won't go into any details here, but basically then amplify the technologies capable of translating that consumer need into biological question. That biological question then is assessed. And then what the technology is capable of doing is looking through many different plants around us, specifically foods we're focused on at the moment, for hidden molecules within them that otherwise we lose when we eat the plant, that actually confer that specific benefit, whether that is anti-inflammation, whether that is improving glucose modulation, and so forth. The AI system is capable of identifying those benefits or those peptides that have been hidden in those plants for hundreds of millions of years. It's only now through technology that we're capable of finding them and bringing them to humans, to consumers. So then we actually produce these powders. So basically, it's simple food processing where we take the source material, we use food enzymes, and we unlock those peptides and benefits. And we create natural ingredients at the end that we then go into testing. So we go in initially in vitro, so in the lab testing whether the AI has identified the right ingredients. And then if so, we continue into preclinical, into human clinical, double-blind placebo clinicals to show that the efficacy, the oral efficacy of the ingredients within humans. And then we scale the ingredients. So we scale in the tonnage level, and then we take it to market through our partners initially, but also launching our own products. So this is the cycle. And what's interesting is that we've done this many, many times, and we've started to launch our own ingredients now since last year. We have accumulated about 12 human clinicals so far, double-blind placebo clinicals, 8 of which are randomized double-blind placebos. We've started to publish our work last year as we were launching our ingredients, our scientifically, clinically proven ingredients. We have a lot of patents, as you can see, and we have moving forward with 3 programs, one in muscle, which I'll explain, one in metabolism, in glucose metabolism, and one in aging with skincare. So it's skin aging. And behind the scene, we have 3 million peptides ready to be developed in different health benefits that we have already discovered, know how to produce, and know exactly what plants we can extract them from. We have been collaborating with many, many companies. Here are some companies, the biggest companies in the world, in different areas, taking these to market and putting some of these products, some of our ingredients within their products too. So the areas we're focused on at the moment through the technology are the first 4 areas. So through the use of AI, we've been able to reduce the costs and reduce obviously the cycle. So it's now sustainable to identify active ingredients with clinical proof and improve the science within the whole food area, within the dietary supplement area, within the whole personal care area, moving into pharma as well. And from a secondary focus perspective, we have collaborated with major companies within the animal health as well, because again, peptides are the major signaling molecule in animals as well. So in the animal health and the ag tech industry as well, with major companies, some of which I've already mentioned in the previous slides. So for me, it has been a really incredible journey personally, but the team behind were incredible as well in terms of when you see something, when you're developing a technology on the computer, to actually see the results that it can create, that are tangible results, creating an ingredient from nothing, identifying a molecule that has been hidden in nature for hundreds of millions of years through AI, and being able not only just to identify it, but being able to make it and clinically test it and scale it and actually sell it as a powder. I think that kind of transition is incredible, and that's really the benefits, I think, of pure mathematics. From behind the scene as well, this is the pipeline of different health areas we're in. Like I mentioned, the first 3 top areas are muscle health, and we're focused on strength, skin health, and metabolism, glucose metabolism, and then other areas we're in that are still under development behind the scene, heart health. We're looking at blood pressure as well in that area, gut health in general, sleep and immunity, obviously, the very big areas, especially with COVID currently. And then food preservation is a big area where it's not about a health benefit here, it's more about a sustainable replacement for something that already exists. So currently, preservation is massive. There are currently 5 preservatives used worldwide. The problem with preservation is that it's absolutely carcinogenic, so it's not healthy, and accumulation of preservatives is not good. So the question is, can we identify a replacement that can that is safe to consume, that does not cause obviously resistance and so forth, but safe for humans to consume, that is plant-based, and that's what we're developing in that area. And then just focusing on the top three. So the top three in the muscle health arena, the ingredient itself, we discovered in fava bean. Obviously, when you eat the fava bean, you don't get the benefit. We focus on three targets: inflammation, a few biomarkers there. We focus on muscle synthesis and muscle degradation. So three different pathways, and we identified in fava bean 3 different peptides. Once released, can target the physiology of the muscle, so enhancing muscle regeneration. Quite a few publications that we've done already. It's the first plant-based muscle health ingredient that fixes the issue. So it's not about nutritional and giving protein to your muscle. It really is about fixing the machinery of the muscle so that we can retain muscle for a lot longer. And it's a massive issue that we all suffer from about the age of 28 onwards. And there are no solutions currently to maintain muscle for longer. Exercise, but exercise works to a certain point. You have then glucose metabolism. So that one, we've clinically tested it in a pre-diabetics publications out. And then the third one is in the whole aging arena. And that one's in skincare. It's from P. And the double-blind placebo clinic has been also published, and it's on the market. So we launched the 2, PeptiStrong and PeptiYouth. PeptiForce is still being developed behind the scene and launched soon. And then we're really targeting on very big consumer demands at the moment. So as you can see, the coverage, so PeptiStrong, for example, covers the whole muscle health arena and strength, but also obviously sport nutrition. But in general, it's a very, very big demand. And consumer demand is the consumer's awareness of their muscle health, which is the major organ we have, which basically allows us to move, to metabolize better, a very important organ. And as we age from the age of 28 onwards, the performance of it degrades, and a lot of other issues start appearing. And so it's very important to maintain it for longer. We are obviously targeting sarcopenic individuals with that as well. Blood glucose and diabetes management through PeptiForce and so forth. So we're really targeting some really interesting segments here. And then one last one here, we actually launched it's a very limited edition. It's a product called Elio Restore, which you can find in Elio Life, which contains PeptiStrong, the muscle area ingredient. And it's a limited edition that we're launching in the US at the moment, and it's doing really, really well. It really resonates with consumers. I just want to quickly thank the team. We have a very big team behind the scene. Here are some of the individuals at the front that are pushing it from a science perspective and AI perspective, but also from a commercial perspective as well. I'd like to thank everyone here. We have a great advisory board team as well behind the scene, like the ex-CEO of PepsiCo and Nui, York from Bayer, and so forth. I won't go into them all. And I just want to really finish off by saying that I think my GP at that time knew very little that, mathematics could be applied to literally anything. I could have applied it to finance, to literally any area. We decided to apply it here, and I think it's a really good mission. We want to be in every home by 2030 inside our foods, our beverages, our dietary supplements with true science behind it. So having buying a product and knowing it's going to work for you, that's truly our mission. We want to improve the lives of billions of people. So please follow us. Thank you.
Thank you very much, Nora. That was fascinating. And I look forward to speaking further with you at the discussion at the end of these sessions. Next up, we've got Paul Duan from Bays Impact. Paul is a social entrepreneur using technology to empower people to collaborate at scale. He is one of the pioneers of using algorithms to create social impact. Over to you, Paul.
Hi, everyone. Very happy to be here as well. As So as you said, I'm going to talk about how we leverage AI and technology to address social issues with our NGO. So I've been doing this for the past few years now. Used to work as a data scientist in Silicon Valley, writing algorithms to reduce fraud for international payments at PayPal and Eventbrite, and then one day just realized that these algorithms that powered some of the world's biggest companies could also be applied to the social sector, and that there was a lot of potential here to create social impact at scale, which is really what we've been trying to achieve for the past few years. To give you a quick introduction about Bayes Impact. So Bayes Impact is a nonprofit organization created in 2014 in San Francisco. We have kind of a big lofty goal, which is to build the future of public services. So we phrase it that way because one thing that we learned is doing tech for good as kind of a use case. It's kind of a case study, I guess. Showcase is one thing, but if you really want to get it out in the field and impact disadvantaged communities at scale, you also need to think about how technology interacts with the public sector and with public service providers. So we have built a model here around creating technology-based innovation that we then deploy through governments. I'm going to give a few examples here in the next few slides, but basically here the one common thread between all these projects is that we believe that for some social issues they exist in such a large scale that we need to harness the power of technology and algorithms if we want to address them. So to give you a few examples, we worked on a few different projects before doing a little bit more of a deep dive on one specific technology that we built. We were we're behind the first use of force, police use of force data collection platform used in the United States. So back in 2015. We worked with the office of then Attorney General Kamala Harris in California to build this tool that helped enable more than 800 police agencies report use of force data, which was previously left unreported. So that enabled a whole bunch of use cases from of course, just transparency and publishing use of force data, but also thinking about how we can use this data to power data analysis around anomaly detection or targeting interventions for different police agencies, by trying to identify which police departments were at risk of maybe more violent behavior, and in what cases. And so here in all these cases, the common denominator was that the need for collecting this data in the first place in order to be able to analyze it. Another project that we have recently worked on, so we built a community-based contact tracing solution called Conotify, which we launched in France a few months ago and helped notify more than 2 million individuals at risk of COVID-19. If you do the ratio with the number of cases in France over that time period, so we covered about a third of the total quote unquote market of COVID infections through that technology. And so here, when I say it's community-based, so what we helped do is create a system that was completely privacy-focused, with no data sharing problems, and so no privacy issues. So it's completely private by design. And we created a system where people who had an infection could easily notify the people they had been in touch with through their own devices, and using the local data on the device to help them remember who they may have met. So that's a system that we built and scaled over the past few months, and which actually performed around 20 times better in terms of number of people notified than the government's official solution. But today, what I want to do is to do a little bit more of a deep dive on one of our projects in order to focus a little bit more on the tech behind it. So it's a technology called Bob, which is a solution around employment coaching that we have been rolling out in France for the past few years, and now in a few more countries as of 2021. So this technology is called Bob. The core issue we're trying to solve here is that, well, as you know, unemployment is a big issue, affects dozens of millions of people in the OECD alone. This is an older figure, of course. With COVID-19, this number has been skyrocketing in quite a few countries, leading to not just a big increase in unemployed people, but also a big shortage of available coaches that governments were able to provide in order to provide employment coaching and counseling services to all their constituents. So there was a big scalability issue here in terms of employment coaching. And so that's an issue that we set out to solve using AI by realizing that using data from the labor market, historical data on what human coaches have recommended to different users and beneficiaries, and what has worked and what didn't work, that we were able to create an artificial coach that could automatically power some coaching services to all job seekers in a cost-effective and scalable manner. So the way that we do this is transforming data into actionable advice that is really tailored and really smartly delivered to each job seeker. I'm going to skip a few slides, but the way it works is for every job seeker, we use Bob's AI to provide this automated coaching, which consists in 3 different parts. So we have an AI engine that automatically does some employability assessment. We then use this employability assessment to recommend an action plan. So we will automatically suggest the best course of action, the best workshops, the best skills to attain if you want to improve your employability. And then based on this action plan, we then match you with different resources and actionable advice that are delivered to you over the next few weeks and months until you find a job. Here's kind of what it looks like. So, on the left, we have this employability assessment. We are able to analyze a user situation based on the labor market, the level of motivation, the skills and qualifications, and cross that with labor market data to say maybe you're above par or below par, or maybe that people who are looking for this type of occupation but tend to lack this skill will on average be unemployed for twice as long. So based on all this, we are able to cook up this employability score, which helps us identify the core blocking factor for someone. So maybe this core blocking factor can be that actually it's a job with a lot of competition, and that means that for the next piece of the AI engine, the type of strategic recommendations we will pair with that assessment will be strategies around maybe expanding your job search or finding more opportunities. For example, by trying to find jobs that have less competition, or jobs with similar skills that you should maybe try to include in your job search. We have been able to scale to 300,000 beneficiaries in the first year in France of the rollout. So that's with an extremely low marginal cost, which means that we're now in talks to roll this out nationwide in France to all the 5 million unemployed people that are currently coached by the French National Employment Agency. And we've been able to get some great results here, with about 88% of people finding Bob's advice useful among those who find a job. So 40% of them attribute the job recovery to the advice we've given them, which is actually twice as high as as the baseline for the benchmark we have for public employment services, and also in terms of personalization. Of course, one thing that we do want to make sure is that by automating employment coaching, we're not trying to dehumanize a public service, but instead trying to really create a system where it is complementary to human coaches and can save also time, so that human coaches have more time for the people who need it most. But in order to make sure that we're not dehumanizing this, another key metric that we have is that we actually have 80% of people who find Bob's automated coaching as personalized as in-person forms of employment coaching. So that was a user testimony here. The really great thing and that we're very proud of is that we have been able to get really human type of feedback when people praise the coaching they received through Bob. You could imagine it would be related to more technical things, like, okay, I've gotten more information on the labor market, maybe I have identified some workshops I didn't know about, but in reality, most of the feedback that we get is actually a lot more personal, a lot more human. It's a lot more about helping provide hope, enthusiasm, motivation, and really helping every individual believe in themselves through the coaching. And that's something that we're quite proud of. As I mentioned at the beginning, so we are a nonprofit organization. Our model here is that we are funded through philanthropy. So we are an independent civil society group. All our IP is open source. I forgot to have the slide with all of our funders, but I'd like to thank organizations like the MasterCard Foundation, the Go.org Foundation, or the Gates Foundation that have been critical to funding this work. So that has really enabled us to kind of start from a blank slate and think with a fresh mindset. If there is a social issue here, how can we try to make it better? And then what happens once we build and test this technology is we find sustainability and scale through public service partnerships. And so one way to think about it is that we see our role as a nonprofit to de-risk social innovation. And that's also how philanthropy plays a hand into that. So we de-risk this innovation that may be kind of difficult to do from within government. And then once it works, we then collaborate with public agencies to provide that at a much bigger scale. And so that has been kind of a common thread with all the different projects that I've talked about before. It's the case with Bob. It was the case with Conodify, where we helped launch the community-based service by ourselves, and then partnered with the National Health Insurance System to scale that up. And overall, the big belief that we have here is that technology can be a force for good. We need all kinds of collaboration from different sectors, of course, from the private sector, but also from civil society, from NGOs, and of course with government. And that's only by working all together that we can make AI work for everyone. Thank you.
Thank you very much, Paul. And don't go away. We'll be speaking to you later in the panel discussion. Next up, we have Andreas Cleve, who is one of 2018's Innovators Under 35. Andreas has created an AI-powered infrastructure that listens to emergency calls and patient consultations to help provide the most effective intervention as quickly as possible. Andreas.
Thank you for having me, and what a presentation to follow up on, Paul. Amazing work. So I represent Cordy, and we are a European-based company with roughly 70 employees, founded in 2016, on the premise that we thought it was time that medical staff got the assistance they need when they interface us as patients. The basic premise that we wanted to solve was the unfairness and inequality of healthcare. The sad fact is that at this point, misdiagnosis in the Western world kills more people than we know from gunshots and strokes and cardiovascular disease combined. And that is not because we have an incompetency problem, that's because we have a resource problem. At this point, this not only is a massive threat to our safety, but it's also a huge cost on our already strained healthcare sector. The major issue here is that we all as patients get smarter and smarter, and we want more and more from healthcare. That's obviously the right way to go forward. We want to deliver more, we want to get more. The problem is that we lack the people to go and be there and support us when we need them. Very soon, according to the World Health Organization, we'll need more than 18 million doctors, and that's only a couple of iterations away. Where we then wanted to start was to see where could artificial intelligence help buy back some time from these strained doctors, nurses, and medical experts and give it back to patients. And our basic premise when we started analyzing it was that a lot of the issues, the faults, and the time constraints in modern healthcare starts where the patient journey starts, and that's with a consultation. Today, we have found more than 86 billion consultations happening across the scope of the healthcare sector every year. The issue is that when you go to your doctor, very rarely will that consultation or the ones you have at the hospital or the clinic or the ER will be documented and quality assured. That means right now that less than 1% of the total amount of patient consultations, which in turn will inform the journey for the patient, it has any kind of quality of control on top. The Mayo Institute, which is one of the premier medical institutes in the US, made an analysis of this and how great a care you could expect at your first encounter with the medical sector. And what they found was if they took 100 diagnoses made in primary care by an excellent medical expert, the problem is just the fact that there is so much to know about the body. And I think back to Nora's point, there's so much still to do that to think that in a casual conversation, in early stage risk assessment can be precise. And what the Mayo Clinic found was exactly that 80% of primary care diagnoses at first turn would be wrong. And even worse, 21 of those would be radically altered if a second opinion was added. So that started Cordia on a journey to think, what if we could help provide some kind of second opinion in primary care to help take some of the workload and some of the risk out of patient consultations? An opportunity arose, which was digitization. And as we all know, healthcare is becoming increasingly digitized, especially as we see the advent of telehealth being rocketed during the COVID-19 pandemic. So just a few years ago, we would have few providers sitting on a large amount of the very physical engagement, whereas the opportunity that has arisen with virtual patient care is that we actually have a lot of very verticalized specific providers who help us or try to help us across our journey on different digital platforms. So what we thought at Cordia was that these digital platforms will be the advent of a platform or an infrastructure that could help reduce these mistakes, reduce misdiagnosis, and in turn help give medical experts time with patients and reduce the time they spend on administration. And that's why we build Cordia, and Cordia in turn build Audia. Audia is our voice-based assistant, a little bit like the technology you know that sits inside Siri or Alexa. And what Audia can do is it's specifically built for patient consultations. So it has not heard about Spotify. It doesn't know how to do fun stuff in a monologue. But what it does, it has analyzed more than 13 million patients talking to their GP, a nurse, or the emergency department, discussing their symptoms, coughing, describing background noises, having a rusty voice, or being anxious. And all of that, we've built a technology that's able to analyze in real time and help assist the medical expert during this consultation. Imagine sort of as an assistant listening in. How it works is that all of these platforms that we can video engage or voice engage our medical experts on actually provides us an access. That means if you are an emergency department operating a 911 or a 112 hotline, or you are a video app interfacing psychologists with patients, then you have an opportunity to implement audio on top. What will happen is that audio will in turn start to listen at whatever is said and shared by both the provider and the patient. And what it will do, it will try to correlate that to a graph we have built across 33 different ontologies within symptoms. That is from the opioid overdose to the cardiac arrest to the COVID-19 case. What we have on these is hundreds and thousands of patients where we've been able to build a bridge between the data of what is said inside a description of a stroke versus what was written in the EHR journal. So we can start building predictive models that during a consultation, we'll see if it can find a comparison between what I'm saying right now and what millions of patients has discussed before me. That allows us to be way more accurate when we discuss with the patients, we ask the patients, and we triage the patients. And even it allows us to do a lot of the documentation for the GP or the nurse, who can then in turn focus more on the actual symptoms and patient consultation. What the AI can do is it looks at 3 avenues in which it has a total of 21 different machine learning models running in tandem in one big ensemble of machine learning models. It will look for progress of a consultation, so what's to be asked, what is to be said, what is to be diagnosed. It will look for content like big platforms and infrastructures like SNOMED or ICD-10 or 11, which is how you document and code your consultation. And it will look at the service level. So is it a high or low paced conversation? Is the sentiment all right? Or is there some kind of anxiety going on? And is there anything correlating to low service level that means that the doctor might be in a position where they should be following up afterwards? The first place we started to add the technology was in emergencies, because we needed a place where we could clinically prove that by having this assistant, it actually works. And emergency conversations are highly critical. They're already recorded and they're documented very well to ensure that every second counts. What we did was we built a full-out RFP clinical trial where we proved that by adding audio to a live conversation at both American and European 112 and 911 hotlines would allow the call taker, the dispatcher, the nurse, or the doctor to actually diagnose something like a cardiac arrest 25% faster, reducing their mistakes by up to 43%, and keeping them on the right path through the protocol, asking the right questions in 92% of the cases, ensuring that liability is low, risk is low, and the structure of the conversation is high. This in turn will help cut cost, buy back time from the medical provider, give it back to the engagement with the patient instead of sitting there spending it on coding, documenting, and quality assuring the calls, because all of that is happening in real time in the background by Audia, who's automatically layering the right information inside the EHR, the patient journal, or the data lake or platform that's hiding behind, to ensure that the doctor knows that there's somebody there, something there, in this case, a machine learning platform that actually does some of the blunt, boring work in the background. Since we started our RFP back in 2018 and delivered in 2019, the top 5 emergency departments of the world joined the research and the RFP and the tests of Cordy. We're covering 15 million people across the world right now. And we've moved into primary care, ambulatory care, ERs, and GP care, which is among our latest developments, as we're spreading Cordy out across the healthcare sector, and with a claimed goal to move from 15 million patients covered a year right now to 1 billion patients by 2025. This obviously is a daunting mission, and we're lucky to have amazing partners from across the globe helping us both on research. We work with some of the best research institutions in both Europe and the US, and have amazing partners, investors, and stakeholders around us to help carry the message forward, as we hope that everybody in healthcare will be able to access medical expertise and great care whenever they need it and wherever in the world they need it, and no matter what kind of country they live in or which kind of medical infrastructure they will be available. What we hope we'll see and what we think will be the next big advent, as we've proven here, is that not only have we proven that AI should be a part of patient consultations and the very open-ended engagements that's happening in healthcare. What we will see soon is that this technology will open up for the opportunity for the third world to leverage the data that we have now trained machine learning and AI models on, and allow that to be set free in a direct voice interface. So even the poorest regions of the world will be able to call, text, and engage healthcare expertise at a fingertip only with the barrier of natural language, which we in turn will hope will be the advent of a new realm in global healthcare, where not only is healthcare expertise democratized, but it's also easily accessible. I thank you for your time. It's amazing to be here, and I look forward to participating for the rest of the day.
Thank you, Andreas. Next, we have Bo Lee, who is Assistant Professor at the University of Illinois and is one of 2020's Innovators Under 35. Bo Lee is researching how input data can be manipulated to compromise artificial intelligence, and by doing so, train AIs to be more resistant to this type of exploitation. Bo Lee.
Hello, everyone. It's a great pleasure to share my research about secure learning adversarial environment with knowledge inference here. My name is Bo Lee, and I'm from UIUC. So we have so far listened to a lot of great techniques from AI and machine learning perspectives. And here I may want to give a slightly different understanding and see like the other side of AI and machine learning, and see whether we can improve and develop so-called trustworthy machine learning pipelines for our world. So basically, we can see, of course, machine learning and AI has been ubiquitous in the world currently. It has been applied to different domains to make our life better. For instance, autonomous driving, intelligent medical healthcare, smart city, etc. And we have heard a lot about them. And also in a lot of safety critical areas, for example, malware detection, fraud detection, etc., has also been benefited from the machine learning and AI automatic techniques a lot. However, everything have two sides, right? So from the other side, we can see even though machine learning and AI techniques so far have brought a lot of convenience for us, but still there are a lot of security and privacy issues brought by such like very powerful techniques. For example, in 2016, the Associated Press Twitter account was hacked with phishing emails, spreading the rumor that White House has been attacked. And then you can see within seconds, the autonomous trading bot dump a large amount of stocks and swipe about $136 billion within seconds. And this is the real world threat happens in 2016. And similarly, from the privacy perspective, for example, the Australia airport have adopted the biometric recognition system for the safety screening, which have raised a lot of concerns. So based on these real-world examples, we can see that although we are living in a very convenient platform environment that provides us a lot of good platforms to help us develop powerful and efficient, effective machine learning pipelines, we're still living in an adversarial environment. Don't forget about that. And therefore, typical machine learners still have a very hard life to develop so-called trustworthy or safe or robust machine learning pipelines or algorithms. And therefore, we really need to try to understand the adversarial strategies near us, and then therefore develop the robust techniques and learning algorithms to give us a certain certification about the safety of the algorithms we are using. And on the very high level, people may wonder, like, what is such reason to cause such potential vulnerabilities of machine learning models or pipelines, right? So we know that in, say, traditional machine learning approaches, there is a certain fundamental underlying assumptions called the stationary assumption. Basically means that the training and testing data should be drawn from similar or even the same distribution. However, in real world, we can see this may not hold true, because sometimes the training data distribution itself could be manipulated in such a way that usually we call it a poisoning attack or backdoor attack or Trojan attack, like that. And basically, for example, from Netflix recommendation or even like Yelp review online systems, you can create some fake account and manipulate the reviews or scoring you give, and therefore generate this very practical potential poisoning attack to poison the training data for the model, right? And on the other hand, it is also possible that okay, you can have a closed system to train a model with clean data, while the attacker during testing time can generate or manipulate the testing distribution. And such attack is usually called evasion attacks, meaning that given a well-trained model, I can still manipulate my test data and generate certain severe consequences. And later on, we will see some examples. And based on this fundamental understanding about the real-world adversarial machine learning and the potential vulnerability and the root cause of them, we can see it's very important to develop the so-called trustworthy machine learning, which is actually the final mission of our lab. So basically, given a pipeline of machine learning system with different types of components, we can see, first of all, it's very important to identify different vulnerabilities, including security, privacy, fairness, etc. vulnerabilities, and then therefore develop the robust machine learning algorithms or certification algorithms to certify how robust the given pipeline of machine learning is, right? And usually this can come through based on different robust feature representation, understanding or certified robustness and feature evaluation, etc. And also it can come from the game theoretical analysis in the later component, and also learn the inference through certain extraordinary information such as human knowledge or intrinsic and extrinsic information from the machine learning pipeline, which we will give some small examples later. And also explanation is important for us to understand and therefore debug the whole pipeline. For example, we can calculate the data valuation so that we know which data point is the most important for contributing to certain predictions we have. Either it's good or bad prediction. If it's bad, so we can come back to debug this data point, like clean up it or relabel it, etc. But if it's a good one, then we know this data point is the most contributional one, so we can improve our sample efficiency or complexity. And of course, later on, the whole paradigm can lead to privacy leakage and corresponding privacy protection methods. And in here, I will mainly give some examples from the adversarial attack and the robustness perspective to see what's the current most state-of-art types of attacks, especially in real-world cases. So here's one quick example that we can generate the physical attacks for some road sign to attack, say, the autonomous driving vehicles. So one example is that very interesting here. You can see all the columns here shows different types of perturbation, like different type, meaning that there are some subtle perturbation and there are some letters and even such just white and black rectangles on the sign. And all the stop signs here, even though to human eyes still a stop sign, but it's targeted to misclassified as a speed limit sign 45. So this achieve this target so that it can lead to the most severe consequences, because the car will not stop at such sign, and it is quite dangerous. And the right-hand sign here is misrecognized as the stop sign itself. So that means different roads actually shows different environment under different like lightning and angles and distance conditions. You can see they are consistently misrecognized by the machine learning models. And this is an example of like a static analysis. We can go to the real world and see this is an autonomous driving vehicle driving on the left-hand side. It's a perturbed sign, as we can see before. And here on the right-hand side is a control experiment. And what we can see is that if you drive the car towards it, and if you look at the caption itself, on the left-hand side is consistently misrecognized as the speed limit, but on the right-hand side, the control experiment can correctly recognize it as stop sign, which raise a lot of like dangerous discussions about such physical attacks. And of course, this is one against like machine learning classification. And of course, in a more complicated environment, such attack can be used to attack the object detection as well, which is one type of model that is very widely applied to different machine learning autonomous driving vehicles. For example, in this stop sign, you can see all the rest of the object can be correctly recognized. Only this stop sign itself, you can never recognize it by the algorithm until you get very, very close to it. It actually recognizes letters, so you can recognize it. But this is too late for a car to stop, and we on purposely do not cover the letters, of course, otherwise it can fool human as well, right? And such stop sign itself is quite interesting, and itself actually is exhibited in the Science Museum of London currently, I think. So if anyone have time, can go to visit. So this shows that such physical like attacks or perturbation actually is a very severe concern that we need to consider if we want to develop so-called like safe like autonomous driving or safe machine learning. And based on such, physical attacks, a lot of people ask, this is only attacking the camera itself, right? And there are a lot of sensors like LiDAR and radar and all the different multi-sensor fusion systems. So like some people may have the hope saying that if we have the multi-sensor fusion system, whether it is possible to detect or defend against such attack and make our autonomous driving vehicle more safe, is that like that. But with a reasonable pipeline of the whole, considering the whole sensor fusion system, like the LiDAR and the camera and every sensor into consideration in both white box and black box access to the system, we can see actually, we can see some simulation examples. Here on the bottom row is against the different types of simulation environment, and we put such 3D printed out the real world adversarial object we called to this scenario, and we can see the car itself, even equipped with multi-sensor system in this simulation, it can never recognize this object and go past it. But if it's like a real object, it will stop here because it recognizes it. So by like a bare eye of human, such object, the adversarial object is quite similar with the benign one, but actually it cannot recognize it. And here is a real world demonstration, which you put this object 3D printed into the real world and drive a car in the highway towards it. And you can see this is a LiDAR result, and the LiDAR can never recognize this object, although it's clearly here. But if you look at the control experiment with a box of similar size in the same position, and then if you go towards it, you can see there is a green box in the LiDAR recognition, meaning that the LiDAR can recognize this box. So it means that on the high level, it's very clear that in the multi-sensor fusion system, it's still not safe, and we can easily print out or generate certain realistic 3D adversarial object and put on the road to fool the potential adversarial potential like autonomous driving vehicles. And more examples can be found later. And so far, given such potential vulnerabilities from different types of sensors of autonomous driving vehicles, there are many autonomous driving companies has collaborated and identified such vulnerabilities and start to investigate and try to improve their robustness or safety testing, etc. And so far, after seeing such real-world adversarial attacks and behaviors, we can see against such attacks, there have already been a lot of works to try to improve the robustness, defend, or detect such attacks. But I can sad news is that lots of such defense or detection methods are not robust enough, and which means it can always be vulnerable against the new adaptive attack, meaning that if I can know or access what types of defense algorithm you are using, it's very easy for the attacker to generate a new types of attack and form a so-called cat and mouse game to try to attack the system again. That means we really need certain like a certificate or guarantees for the robustness. And therefore, there are certain like line of work to develop the so-called certified robustness for improving or give the certification. And there are a long list of it, and I give some examples. But the one drawback of such line of certified robustness is that it's not, most of them, like all the one work in this branch is not scalable enough. For example, it cannot scale up to large-scale dataset, such as ImageNet. And only this branch, which gives a probabilistic certification can scale up to large data set. But still, so far, the conclusion is that there is still a large gap between the so-called certified robustness and the real benign accuracy. For example, we can train a machine learning model and achieve, say, 97% accuracy easily, but the certification is still like 60% or even 50%. There is a big gap. And the certification here means actually the lower bound of the accuracy, given certain constraint of the attacks, for example. So to fill this gap, there is a long way to go, and a lot of important techniques need to be proposed. And one I personally think very promising direction to improve or fill in this gap is robust learning with reasoning component empowered by knowledge. So basically, we can see all the examples we showed before in the adversarial cases cannot fool human, right? It can only fool machine learning models. So this gives us insight about how we can leverage human knowledge or human inference or experience or certain things and map it to machine learning models to improve the certification of it. So here is a simple pipeline. We use a reasoning component extracted from knowledge, which can be realized by certain probabilistic graphical models like Markov logic nets or in Bayesian networks to have this end-to-end certification. And actually, it is very hard problem in the sense of reasoning is a Sharpie complete problem, but it is possible to certify it given the structures of probabilistic machine learning models. And of course, there are a lot of details that can be improved, but just briefly, we can see all the robustness improvement and the benign accuracy can always be boosted by such pipeline with knowledge incorporation. And more details we can discuss during the panel as well. And thank you, everyone. Yeah, that's the end of my talk.
Thank you very much, Boli. We're going to talk again in a few minutes after our last innovator. And our last innovator is Daniele Pucci, who is a researcher at Istituto Italiano di Tecnologia and is combining humanoid robots and jet-propelled platforms to deliver food and medicine during natural disaster scenarios. And it sounds really interesting. Over to you, Daniele.
Hello everyone. Thank you very much for having me here. So as it was mentioned, I am Daniele, and I am a research scientist working in robotics, and more in particular in humanoid robotics. And so what we're trying to do at the Italian Institute of Technology is to understand how humanoid robots can help us face the next challenges. And in order for us to understand what are the next challenges, what we can start is to start with data and understand the current trends. And when you look at data and current trends, there are a couple of facts that really require close attention from the scientific community. First, aging. So there are basically estimation that by the 2050, 2 billion people will be 60 and older. What does that mean? Well, that means that we need technologies in order to assist us during the daily activities. And also we need technologies that can basically replace humans in all those tasks where an older generation of human beings cannot be effective. Secondly, the second data that is really interesting to look at is that one concerning natural disasters. So there are about 300 natural disasters that kill every year 60,000 human beings. So in this video, you see the city of Minamizanruko during the 2011 tsunami. And then the tsunami also hit the nuclear fission plant of Fukushima, where simply human beings could not enter and be effective in saving and secure the place. So in all those cases, we need technologies that can operate in place of human beings in order to reduce the risks of losing other lives. Then the other statistics, it's for sure around the current pandemic. So the current situation of COVID-19 clearly highlighted that we need technologies that can really operate when humans cannot be out there. So, and this technology basically has to act in an anthropomorphic environment, which means an environment which is made and thought and conceived for humans. And we have been doing that for thousands of years. So all these technologies basically should somehow look like humans and should basically use the power of artificial intelligence. So as a research scientist, the next problem would be, how can I use AI to face the next challenges? Well, if you look at the AI algorithms nowadays, so also the former colleagues showed some examples, the performance are incredible. So there are AI algorithms that are able to beat humans in very, very complex games. So probably most of us knows about the AlphaGo, so the AI algorithm by Google DeepMind, which was able to beat the world champion of Go. But when you look at this picture in particular, there are a couple of facts that clearly highlight the complexities that arise when trying to use AI algorithms in the real world. First, the game itself. So clearly, although games are really complex to solve, but although the computational complexities of certain games, for sure, this computational complexity does not match the real life of human beings involved in daily tasks. So if you think about it, games are defined by a set of rules. And independently of the complexity of the games, basically these are a finite set of rules. And the other big challenge that there is actually the other human itself. So if you think about it, all the powerful AI needed a human being to move a single stone and to place it in the right place. So the incredible, powerful amount of AI algorithm and performance did not match the simple task of moving a single stone. So what do we understand from here? Well, we understand that in order to make AI algorithms effective, we really need standardized bodies in order where to test these algorithms. And actually, if you think about it, and if you think about the human race, our intelligence developed on a standardized body. So the fact that we were able to become intelligent as creatures basically is intimately related to our body. And if you think about it, and if you study, you understand that, for instance, the role of the opposite thumb of the hand had an incredible role in developing intelligence. So what does it mean? It means that in order to take the AI algorithms onto the real floor and to basically face the big challenges of humanity that require interaction with the environment, we need not only artificial intelligence, but also mechanical intelligence. And this is what we have been trying to do at the Italian Institute of Technology over the last basically decade. So we have been working on ICAB. ICAB is a standardized platform for developing AI algorithms. And ICAB is a humanoid robot, which basically which basically had the objective of being an artificial being that was able to learn by interacting with the environment. So the intelligence of ICAB basically exploits the many sensors that ICAB is equipped with and are basically bio-inspired. And the many sensors, for instance, are the skin. These tactile sensors that all over the body give us information about where we touch the robot, or even the eyes, which really reflects human eyes because they work only with variations of images. So over the last decade, the intelligence of ICAB has been polarizing around two main categories. And it's nice that we underline that these two main categories basically reflect the intelligence of any artificial being that has to interact with the surrounding environment. And these two intelligences are basically the cognitive intelligence and the motor intelligence. So what is the cognitive intelligence? Well, the cognitive intelligence is basically what is allowing me right now to make a speech. So all the capacity of human being, which is able to deduce information starting from incomplete data, which means that I am using basically my experience, it is basically a form of cognitive intelligence. And it is important to highlight that the cognitive intelligence of humanoid robots and in general of artificial beings really exploit the subcategories of the AI tools. So, for instance, those of supervised learning and unsupervised learning. And these subcategories are somehow narrow with respect to the entire large variety of the of the artificial intelligence algorithms as a whole. So when you implement cognitive capabilities, for instance, onto ICAB, behaviors of this kind can emerge. So ICAB can, for instance, recognize objects, understand where they are, and if he has to clean the table, he also understands how to move around in order to clean the table. So these tasks that may be really simple in front of human beings, which have been evolving for million years, somehow arise naturally from the cognitive intelligence of ICAB. So this is something that is important. So the other big intelligence that characterizes any artificial being is clearly the motor intelligence. So the motor intelligence is what allows us to move around the world, around the environment. And when dealing with humanoid robots in particular, if you want to make a humanoid robot move, you cannot simply neglect the human being. And here, well, we should dig a little bit into the evolutive biology that characterizes the human being. And so, long story short, 6 million years ago, humans somehow became started moving on two legs, stopped being quadrupeds. And the main two reasons for doing that was that we really wanted to minimize the energy while locomoting, and also we wanted to have the manipulation capability. So we wanted to basically use hands. So when you take these two principles and then you implement them onto humanoid robots, as a consequence of the principle, you have some behaviors arising from the motor intelligence. So, for instance, here ICAB has the objective of being of balancing, so he has not to fall, and also has to be compliant. So, although you clearly have nowadays robots that do the backflips around, you cannot really touch them. So, the power of the motor intelligence that we have been trying to develop was to endow robots with compliant capabilities for interactions, which is exactly one of the capabilities that was missing in the beginning of the presentation to the AI algorithms. Then analogously, here the leap is a giant, but just to long story short, analogously, if the robot has to look forward in order to walk, basically he has to understand to walk by falling. This is basically a paradigm that you understand when analyzing human beings. So we move around by falling. And when you implement this kind of algorithms onto standardized platforms, basically the robot starts moving as human beings. So basically you have this decomposition of the intelligence, and this decomposition characterizes any artificial being. One of the things that you may do when doing humanoid robotics is that the cognitive part of the robot can be delegated to the human. Because theoretically, what you may think is that, well, since human beings have cognitive intelligence, why do not I delegate it? And that's when we talk about teleoperation. So all the teleoperated robots, what do? We simply delegate the cognitive intelligence of robots to a human being. So there are nice applications nowadays with humanoid robots in terms of the so-called teleexistence, where we can even envisage to transport human beings using robot avatars, which can map humans on the other part of the world. So in this video, you see Mohammed that moves around, and if the robot moves, if Mohammed moves, the robot moves. Clearly here there is a problem of projection, because the motion has to be projected onto the robot, which is indeed different from the human. And the nice thing is that when you project the motion of the human, you may attempt also to project not the motion, but the emotions of the human. So the acceptability of humanoid robots of the future really will depend upon this, on the capacity of transferring not only emotions, but also the psychological state. The story changes a little bit when you want to integrate human beings inside the loop, because when humanoid robots have to collaborate with humans, the task for sure becomes more complex. And it becomes more complex because, for instance, if there is the humanoid robot and the human being that want to collaborate, Well, the humanoid robot has first to sense the human beings. So in this video, for instance, you see Claudia, which is helping the robot to stand up from a chair. What does that mean? Well, trying to mathematically translate the fact that the human wants to help the robot is indeed a challenge. But once you understand that, you basically can reverse. So humanoid robots can be allowed to help them, to then help humans to achieve physically challenging tasks. And the nice thing is that all these algorithms for motor intelligence complemented by humans really scale up nicely when you substitute the human with another human. So in the future, we can really envisage somehow humanoid robots which collaborate with humanoid robots that collaborate with humans that maybe have prosthetics and then to achieve common objectives. Well, some of the open points clearly when you work with humanoid robots is how to use humanoid robots and their intelligence in order to go beyond humans. And the problem of going beyond humans clearly is a nice challenge, but let's try to understand why we need this. Well, this is a notorious city, once again, after the tsunami. So what do you see here? Well, you see floods, you see fire, and then there are survivors to look for. So you really need platforms that can overcome and avoid floods and fire, can land onto specific places, and then can look for survivors. So you need platforms that combine aerial locomotion, so they need to fly. Then you need the platforms that can interact with the environment, because if they need to close a valve in order to avoid explosions, they have to. And then you need to do indoor inspections for looking for survivors. So when trying to combine these three capabilities, the exercise that I've been trying to do is to basically make and allow ICAB to fly. So we have been working on the so-called Iron Cup project, which has the objective to take jet turbines and then extend the locomotion capabilities of the robot to make it fly. So one of the big problems here clearly is how to extend all the control algorithms and more precisely all the intelligence of ICAB in order to basically develop something that is not bio-inspired. There is no flying human around. So trying to understand how to make a flying humanoid robot is not an easy task. But basically the overall robot looks like this. So you have 4 jet turbines that basically power the robot and then can give it the capabilities of fly. This is basically an ongoing work, and we are now at the stage of making the first flight. So if you want to know more, just stay tuned. Thank you very much.
Thank you very much, Danielle. Okay, so we have 5 brilliant individuals, entrepreneurial researchers, or I guess entrepreneurs who research. But unfortunately, we've only got about 20 minutes. So unfortunately, we're not going to be able to, I guess, cover more than just scratching the surface on the various areas. So we'll just jump right in, if that's okay. Do we have everybody? Okay, yep, so got everybody. Guess this was probably quite a nice session because it kind of summarized or reinforced a lot of the messages that came in the previous sessions. Sorry, I heard an engine in my ear. It was distracting me. So it kind of reinforced a lot of the messages from the previous sessions. And particularly, I guess, as Nora and Andreas were speaking, I was taken back to the point that was made earlier in the cybersecurity talk, that we've gone beyond human scale problems. And I guess, Nora, I mean, if I'm right in interpreting what you said, it sounds like what you're doing with NURITAS, with the peptides, it could not have been done without the application of machine learning AI, or is it the application of pure mathematics?
Absolutely. For me, AI stems from pure mathematics, so it's all one. But what we're doing today could not be done with manual ad hoc research currently. That's worldwide, used worldwide by pharma, by consumer companies, etc. So I think there was no way to identify and accelerate the discovery of active molecules in nature without the use of new technologies.
Okay, and Andreas, I guess from a Corti perspective, it sounds like you're using insights derived from, I think you said something like 84 billion potential calls. Again, that's a problem that could never have been solved just by applying straight human intelligence, or certainly could never have been done effectively. Is that correct?
Yes, the total market is 86 billion, and we're currently looking at a little bit more than 13 million. And I think obviously the advent of machinery, or at least the use of machinery, is intertwined with the computing power available and the massive changes we've seen there in cloud computing and that enablement. And if you look at one of our cases where we can do the whole computation of a quality assurance case on a patient claim, that could take up to 90 minutes just for the first run through of a case. So 90 minutes of a nurse or a doctor doing paperwork, whereas we can do it in a few seconds. So I think that's the kind of scale we see, and obviously it's a compound effect of multiple technologies coming together.
Okay.
And could never have happened before we had the ability to stitch together these solutions.
Okay, and I guess it sounds like Corti is a good example of how AIs can work in collaboration with humans as opposed to replacing them in the scenario, be it, I guess, expediting emergency response, be it, I guess, providing greater depth of context to patient conversations.
Absolutely correct. And I think the vision for a no technologist in healthcare can be to replace healthcare professionals. It's called healthcare. And I don't think necessarily, although we will make massive improvements in automation, I think the role is very much still a human-to-human industry. It's just much more setting people up for the right kind of success, doing the hardest, most human quality-based work they can possibly do at any given point in time. I think that's much more about rephrasing what we think is work and what we think is important work. And I think that is actually much more of a framing transition that just happens way faster in this labor market and with this technology than we've seen historically.
Okay, and Paul, on a similar theme, what's your vision for the complementarity between AI-powered coaching and human coaching?
Yeah, I think it's really similar to what Andreas just said. It's really about having some kind of blended model here where you use AI for what AI is best at, which is being able to do, I guess, the simple things with the heavy lifting really quickly and on a large scale. But then at some point you need the human touch, you need the complex stuff that does require empathy, sometimes also face-to-face contact. And that is something that cannot be replaced. But one thing that we have seen is that, especially now after COVID, but even before COVID, sometimes you had extremely long wait times for social services. So you had people, for example, who would sign up for unemployment benefits, and then their first appointment with a human coach would be scheduled in 4 months. That's 4 months where nothing happens. They don't receive any help. And so here, what we have been advocating for is a much more virtuous system where we're not replacing anyone. It's just, can we provide AI coaching from day one to everyone as opposed to in 4 months? That in turn means that we save time for the human coaches, so that when they do see the person, some of the work has already been done, so they can go directly to the deep stuff that only they can do as a human. And furthermore, it can also mean that with AI, we can also identify those who may potentially need to be fast-tracked, because we've saved time across the overall system. Now we can say, okay, well, before in the older system you need to wait 4 months. Now in the new system, if you are high risk, then you can see a professional immediately. So that's how we see the complementarity.
Okay. There's a much longer conversation around, whether AI is ultimately a net positive or a net negative for humanity. We'll assume that it's going to be an optimistic outcome for now. But I guess, Bo Lee, your work, I guess, assumes that AIs will be compromised, that they will be exploited, that there will be bad actors. How do you think that your work can be applied in other areas beyond, say, some of the visual work that you've done to date, in perhaps some of the more patient-centric or care-centric environments that your colleagues work in?
Yeah, exactly. Thank you for the nice question. So we actually indeed have some collaborations with the clinical hospitals about, for example, there are a lot of not only like MRI and vision recognitions from the hospitals, which from the medical perspective, we need to improve their recognition and improve the clinical outcome prediction. Also, there are a lot of electrical medical records from the NLP perspective, and those have a lot of privacy issues. Say we cannot just simply mask the names or the identities out, right? We need to have a more adaptive way so that we can protect privacy and make inference. Also, we hope these types of prediction will not be, attacked, as I show in the vision perspective from NLP. We also show that if you only change, say, one letter or small word, or just to change the tone of the sentence, it could have dramatically different outcome prediction. So how to avoid that and improve the robustness for such prediction is also like our ongoing work. In addition, we can say, how can we publish this data set, right? Like medical data set is very privacy sensitive. How could we publish them to different universities and research institutes so that people can leverage such knowledge and the data to train models and try to explore the potential conclusion or associations within them? This is another big issue. So we kind of also developed the high dimensional differentially private generative model, meaning that if we generate the data, we can guarantee when you obtain the generated data, you will not be able to recover the training data, which are sensitive, so that you can be conveniently use the generated data to do whatever analysis and discoveries from such synthetic, but preserving the statistical association of the previous sensitive data.
Okay.
So these are some examples.
Thanks, Bo Lee. Danielle, your work is fascinating. It's automatically attractive to an engineer like myself. But I guess, what are the challenges that you're finding, I guess, taking the fundamental research and starting to apply it in ways that have a real positive effect? And I'm not, I guess, unaware of the potentially negative effects of the technology as well, but what challenges do you have deploying it in a very positive impact way, helping people in disaster scenarios? What challenges have you had?
Yeah, so prior to be somehow positively deployed, you have the problem of deploying the artificial intelligence algorithms, because as long as you somehow stay inside the simulated world, somehow there is a sort of control. There is an entire branch that is called the simulation to reality, and especially for people doing robotics, trying to transfer AI algorithms onto the real world, especially when humans are put into the loop, there is really a big challenge. So trying to somehow deploy any AI algorithms for either cognitive or motor intelligence especially when agents have to interact with humans. So this is really a big challenge. I mean, sometimes when we come back home, our wife or husband or basically understand our state by saying, "Hey, honey." So you can understand the complexity of then a robot has to somehow understand the human that has to eventually collaborate with them. So concerning instead the disaster response and trying to deploy the disaster response technology, that is a completely different field. So we're trying basically to do something that was never done before. And here the journey is exciting on the one hand, and somehow also risky on the other one, because I mean it's technology that is not easy to deal with, and there is no really clear path to somehow understand how the solution will look like. So yeah, these are the big challenges that we nowadays have in the lab.
Thank you. Nora, you've come quite a long way in your journey, I guess, to commercialization. I mean, what were the main challenges that you encountered? And I guess, what maybe surprised you most going from the fundamental research to where you are now?
That's a big question. Where do I start? A lot of challenges, from literally everything, from the very beginnings of, this is impossible, to, starting it and proving that on a cell, this thing works. On a cell, we can actually identify things of nature that work in cells, to going then into, humans and making sure things are already available. And I think the biggest thing when you're going from a pure tech area where things go really fast into life science, where things are extremely complex and our knowledge as humans is limited and we don't even know how much we don't know. I think when those two industries clash, there are, delays and things because there are things you can't speed up. You can't speed up a clinical, it takes the time it takes. So it's interesting because life science is slow. You're trying to speed it up as much as you can, but there are things you can't still speed up. And I think biggest challenges really are, timelines. It's not, it's not an overnight solution. It takes time, and you have to take with you people that know that journey and know that these things take time. But when you create that IP and when you take it to market, it's superbly valuable, and you're transforming the health of people. So I think that kind of that whole case comes with everything from the types of people you pick, from the types of investors you pick, to the choices you make throughout. So everything's challenging, I think. It has been challenging throughout. But when you're seeing things go to market and you see individuals buying it, that it makes it all worthwhile.
Okay, and if you had one piece of advice for the young researchers, I guess, just starting out, what might that be?
I think for me, it has been always follow your passion, be extremely adaptable. So, listen to the right advice, identify the right individuals that have, gone through the journey previously and have succeeded, and try and adopt as many of those decisions. Try and identify if you're, if you want to, for me, when I was leaving my academic career and going into a more industry career, that leap was hard to make. But for me, it was a question of, do I want to publish and my research will be just limited to that publication, and then, get a few references from individuals that read that publication, or do I want the publication to go further into a product that individuals at the end will use? And that was the decision for me. That's what I wanted. I didn't want to stop at a publication. I personally wanted something that would transform human health. So I decided to take it. But I think the realization that things don't come overnight, that it does take a lot of work and a lot of grit and a lot of pushing and against the tide, because you're innovating and you're creating something you can't just Google and find. Everything's cutting edge.
Super.
It's not easy, so you have to, you just have to go into it knowing that.
Thank you, Nora. Andreas, I guess same question, a piece of advice for the young innovators following your path?
I'm so boring. I'm going to double down on what Nora said. I think if you're never going to get through it if you don't love what you do. And I think finding the small wins and really celebrating them. I think I'm so bad at it. I kept being told by my people. But I think it's something I learned quite a lot from. And I think it's very important when you're with your team is to make sure to see them and experience them, because the path will be so long. So if you don't find milestones and you don't celebrate them and you don't enjoy the work, enjoy the movement, enjoy the everyday, then there is a lot simpler things to do.
Thank you. Paul, same question?
I would say one is really to surround yourself with the right people. It's kind of similar to the advice being said before, but especially if you want to do something worthwhile and meaningful, it's actually really difficult. I think there is kind of this idea that because you're trying to do AI for good, or you want to do something that has a purpose, you wake up every day feeling great, like you're fighting a good fight. This is not true. You have as many hardships as anyone else, and probably even more so. And that's something that you can only do, indeed, if you do love what you do, but also if you have the right people around you. I think everyone here will agree that the quality of the team is extremely important, but also the quality of your partnerships. Having the right or the wrong partner can completely kill a project. We've done things, working with some government partners, for example, where we had everything lined up to have a lot of impact, and it completely derailed because people were not in for the right reasons. And conversely, we had things that were amazing, where just in the span of like 2 weeks, we did more breakthroughs than we did in 2 years. And so that boils down to really having the right partners and the right mindset.
Okay, thank you. Bo Lee, any advice?
Yeah, I agree with everyone just said. And also, I think one main advice is that don't be quite eager about your achievement, your progress, because maybe usually for the big achievement, the progress is not growing linear. It may be exponential. So at the beginning, you may not see a lot of progress, but be patient, and if that's what you like and you have passion on, just to keep going and keep digging into it, I think you will see your achievement and your big progress in the end, definitely.
Thank you. And Danielle?
Yeah, so I share some of the comments that my colleagues did. I am a little bit skeptical about the follow your passion. I tell you this honestly. So why? Because sometimes, especially young people, don't know what they love. And this, may happen also to us, right? As sometimes we don't know when we fall in love with our wife. There is no exact moment that we fall in love with our fiancé. So sometimes you start doing something, okay, and you don't know actually if I love, because sometimes the young people tell you, I don't know what I like. I really don't know. So my advice actually would be to analyze, first of all, the micro routines that the young people have. So do not waste time. Time is really as high value. So do not waste time. Try to understand what you do daily. And if you integrate that in time, it will make a difference. And then there is another message I want to tell them. Perfection does not exist. So people that aim at perfections, so simply they block their productivity. Try to iterate and try to improve progressively by making small steps one at a time. So in this journey, then accept failure somehow as part of the learning process. So really failure, and as the AI community knows very well, reinforcement learning, for instance, indeed is part of the learning process. So take failure as part of the learning process and structure your micro routines so that you can overcome failures.
Thank you very much. Now, I'd love to continue this conversation, but there's a voice in my ear saying that we're out of time. If we can find a way to continue the conversation in another forum or vehicle, be delighted to do that, and we'll be in touch. But thank you very much, everybody, for making the time to come and speak to us. And the audience, small though it is in Titanic Belfast and across the rest of the EdTech community, is really appreciative of your time. So thank you.